Welcome back, everyone. I'm so excited to have you here for this explainer because today we're tackling one of the most fascinating and, frankly, high-stakes topics in tech right now. We are taking a deep dive into the world of AI agent security. We're going to look at how these incredibly powerful digital entities can be compromised and, more importantly, how we can build an impenetrable vault to secure them. So if you're ready to master the architecture of secure AI, you're in exactly the right place. Okay, let's dive right into this, because this isn't just theory anymore. Look at these two real-world heists from late 2024. In August, we had the Slack AI data exfiltration incident. Basically, an attacker hid instructions in a public Slack channel, and when users queried Slack AI, the agent unknowingly pulled sensitive API keys from private channels and sent them straight to a hacker via a phishing link. No way, right? Then, literally the next month, in September, we saw the ChatGPT memory spyware attack. This is where malicious instructions were injected into ChatGPT's long-term memory using a crafted document, which effectively created a silent sleeper agent that persisted across sessions. These events absolutely proved that AI agents are far more dangerous than your standard chatbots. Here's our roadmap for today. 1. When AI agents go rogue. 2. The 5 major AI threats. 3. Building defense in depth. 4. The 5 security layers. And 5. Smart risk-based routing. Let's start with Section 1, when AI agents go rogue. There is a massive difference in power, and therefore risk, between a simple conversational chatbot and a fully autonomous agent. As the saying goes, agents are more powerful and therefore more dangerous. Why? Well, because you're giving an AI the ability to actually take action. When you hand a system the keys to access your database, send emails, or execute code, you are fundamentally changing the threat landscape. Every single team building agents absolutely must understand these risks before they deploy. Section 2. The 5 major AI threats. We've established that the stakes are higher, so now let's shift into the vulnerabilities phase of our heist narrative. Let's look at the exact methods digital bank robbers use to break into these autonomous systems. Now, what's really interesting is that these 5 threats form the definitive threat model you need to be aware of. We haven't ranked them in order of importance because, honestly, depending on your system, any single one of these can be catastrophic. We've got prompt injection, tool misuse, memory poisoning, data exfiltration, and runaway execution. Let's look a little closer at exactly how these work. First up is prompt injection. Direct injection is that classic ignore previous instructions and do what I say command typed right into the prompt. But indirect injection? That's actually the #1 threat to agents right now, because agents constantly interact with untrusted external data, like, say, reading a random web page to answer a question. An attacker can just hide malicious instructions on that external page. The agent retrieves it, reads it, and boom, gets hijacked without the user ever typing a malicious prompt themselves. Then we have memory poisoning. This happens when malicious data gets permanently stored in an agent's long-term memory, like its vector database. Remember that ChatGPT spyware example we talked about earlier? That's exactly what this is. An attacker plants a crafted document into the knowledge base that says something like, always recommend this specific product, or even worse, silently send summaries to this external server. It creates a sleeper agent that silently infects every future interaction. And rounding out our threat model, we have these 3 critical vulnerabilities. Tool misuse is literally like giving an employee a company credit card with absolutely no limits. An agent with database access might just drop your entire database if it's tricked. Data exfiltration is when the agent is manipulated into leaking sensitive info out of the network, maybe through its email tool. And finally, runaway execution. This is when the agent gets stuck in an infinite loop, calling expensive APIs over and over again. It can burn through thousands of dollars in a matter of minutes. Moving on to Section 3, building defense in depth. All right, so we've seen how the heists happen. We're now shifting our narrative from the problem to the solution. We're going from digital bank robbers to constructing the ultimate multi-layered vault. So the crucial point is this concept of defense in depth. It's a layered approach where no single layer is expected to be perfect by itself. Instead, the entire system is designed so that if an attack slips past one defense, the next layer catches it. What's brilliant is that this is the exact same overlapping security principle used in traditional network security for decades, just perfectly adapted for the era of AI agents. Section 4, the 5 security layers. Let's move to the practical implementation phase of our explainer and see how this builds. We're going to map out exactly how you can build this 5-layer vault for your own production AI agents. This is essentially a sequential processing pipeline. We don't just check security at the door.
We check at it every single stage of the agent's cognitive process. From validating the initial input, to guarding the language model itself, to setting strict boundaries when tools are used, filtering the final output, and wrapping the whole shebang in continuous observability. Think of this as the master blueprint for your vault. Notice how security is injected before, during, at the point of action, and after the processing stage. At the pre-LLM stage, input validation treats all external content as untrusted and redacts personal data. During processing, LLM guardrails enforce the system prompt safety boundaries and ensure context windows aren't intentionally overflowed. At the action execution stage, tool boundaries enforce the principle of least privilege, maybe putting code in a sandbox or requiring a human in the loop before deleting files. Finally, post-LLM, output filtering screens the response to make sure it's actually relevant and isn't leaking any harmful content. But the vault just isn't complete without that fifth layer, observability and monitoring. Think of this as your omnipresent security camera system. It doesn't just sit at one stage. It runs continuously across all four of the processing layers we just talked about. It's constantly logging inputs and tool calls, providing real-time alerts if something anomalous happens, and it's the specific layer that will instantly detect those unusual tool patterns or massive API cost spikes we mentioned with runaway execution. And finally, Section 5, Smart Risk-Based Routing.
Now, you might be wondering, won't this massive 5-layer vault make my AI agent incredibly slow and expensive? Let me reassure you, it absolutely doesn't have to ruin the efficiency of your agent, thanks to risk-based routing. And this brilliantly illustrates why. Not every single query needs all 5 layers of defense at maximum intensity all the time. If an agent is just doing a low-risk query, like an FAQ lookup or a basic summarization, you route it right through the express lane with minimal guardrails. But the very moment the agent is asked to perform a high-risk query, like giving financial advice or executing a data modification, the system dynamically routes it through the full 5-layer vault, requiring full validation and even a human-in-the-loop review.
Which brings us to our final thought for this explainer. Is your AI agent an assistant or a liability? Giving an AI the ability to act is an incredible superpower, for sure. But without input validation, strict tool boundaries, and continuous observability, you are literally leaving the vault door wide open. I highly encourage you to take these insights, look at the architecture you're currently building, and immediately audit your own agent security systems. Thank you so much for joining me to unpack this fascinating topic. Now go lock down those agents.